Assalamu alaikum everyone. I hope you guys are good. So in this video, we are going to solve some past paper questions, specifically some P1 past paper questions. So let's get started. Okay. Now this is the first question. Find the integral 2 by 3x cube minus 1 by 2x cube plus 5. Now again, we have to integrate. And how do we integrate? Now this is a very easy question. We know that, let's say if we have x to the a and we have been asked to integrate it with respect to x, what we do is we add 1 to old power was a, so we do x to the a plus 1 and we divided by the new power plus c. Okay, that's the constant. So this is how we integrate. In this question we have this and this. We have three terms. We will integrate them separately. Okay, so let's do it. All right, so we will get 2 by 3 x cube will become x to the 4 and we need to divide it by the new power, that is 4. So this is the integral of 2 by 3 x cube. Then we have minus 1 by 2 x cube. Okay, so x cube is in the denominator. When I bring it in the numerator, I will write it minus 3 plus 1. The new power is minus 2. So I will multiply it by minus 2. And the integration of 5 with respect to x is 5x plus c. Okay, because this is not a definite integral. We don't have the limit. So we write down the constant. I can write it down by cancelling it first. So I will get 1 by 2 into 3 is 6. X to the 4 minus into this minus will make it plus 1 by 4. This is x to the minus 2, so I can write it x square plus 5x plus c. Okay, so this was a 4-mark question and this is how we do integration of simple x question. Okay, now let's talk about the next question. Okay, so this is the second question. Given that this is an equation, find y as a simplified function of x. Now they want us to find y equals something that has x, right? This is a basic understanding of the question. But if we have a look at the question, we do see that x and y are in the power, right? They are not um, in the basis, they are in the power, right? They are the exponents. So we need to do something different this time around. So let's do that. So I know that since they are in powers, I will try writing down every number as 3 just so I can compare both sides and cancel out both 3's and equate the powers. Let's do it. Okay, so we have 3 to the x divided by 3 to the 4y equals. Now I have 27 here. I know that 3 multiplied by 3 multiplied by 3 is 27. This means that 3 cube is 27. So I can write it as 3 cube. And under root 3 can be written as 3 multiplied by 1 by 2. I can take this to the right side and that would be multiplied. So this is going to give me 3 to the x divided by 3 to the power 4y equals, sorry, I need to take this to the right hand side. So I will not write it here. And this will give me 3 to the cube into 3 to the 1 by 2 multiplied by 3 to the 4y. Now we need to use a rule. The rule says when bases are same. What is base? 3 is base, 3 is base, 3 is base, 3 is base. And they're being multiplied. We can write it as one base and add all the powers. So on the left hand side, we only have 3 to the x. So we will only write 3 to the x. And on the right side, we have 3 3's that are being multiplied with different bases. So I can just add all the exponents, all the powers with one base, right? This is a rule. Okay. Finally, I can just cancel out this 3 and this 3 because they are same, and I can equate powers. So power on the left side is x and on the right side is 3 plus 1 by 2 plus 4y. Again, we are very close, but the question is find y as a simplified function of x. Okay, so we need to make y the subject. So this is going to give me x equals 2. I can take LCM. So I have 1 here. I will multiply it with 2. So I will multiply the numerator with 2 as well. 6 plus 1 plus 4y. This is giving me x equals 7 by 2 plus 4y. Okay, now what do? I have to take the 7 by 2 here. That is going to give me x minus 7 by 2 equals 4y. And finally, since I want y as the subject, so I will take this 4 as well. And this time I am going to get x by 4 minus 7 by 2 divided by 4. That would be this equals y. And I can rewrite it as y equals x by 4 minus 7 by 8. Okay, so this was the question. We were asked to write down y as a simplified function of x, and this is what we got at the end after comparing the powers, because on the both left hand side and right hand side our base was same, right? Our base was 3, so we can always just cancel out the bases and compare the powers directly. Okay, so we are done with the second question as well. Let's talk about the third question. Okay, so here's the third question. The line L1 has equation 3x plus 5y minus 7. Okay, I did not read all of the question. So far, I just know that this is the equation of a line and I need to refer to the general equation of a line. So we know that y equals mx plus c is the equation of a simple line. This is the gradient of that line, or maybe the slope, whatever you call it. And this is the intercept, right? This is the intercept. Let me just write it down. This is the intercept. Okay, now let's read the question. If line L1 has this equation, find the gradient of L1. Now this is the equation of L1, but if we compare it to the general form, we do see that it is not in the simplified version, or it is not written as how we write down the equation of a straight line. So we have 3x plus 5y minus 7 equals 0. Let's try writing down this equation like this equation. Okay, so in this equation we have y as the subject. Let's try making y the subject. So I will have 5y equals minus 3x plus 7. I've taken this 3x and minus 7 to the right side, and y equals minus 3 by 5x plus 7 by 5. I have divided both of these by 5. Now we need to understand one thing. Why did I write it in the general form? Because I know that this is the general form and this is my gradient. I am interested in finding out the gradient of L1. So if this is the equation of L1, this number written next to x, the coefficient of x is the gradient. So the answer to part A would be minus 3 by 5. Okay, right. Let's talk about the second part. The line L2 is perpendicular to L1. Okay, stop here. Line L2 is perpendicular to L1. If this is slope of L1, if this is the gradient of L1, so we have a rule if we have two lines, let's say L1 and L2, which are perpendicular to each other, the product of their slopes is -1. I need to find M2 of the perpendicular line. Okay, so I did not read the question. I'm just trying to do as much as I can, just so things become very easy. So M2 is -1 divided by M1. What is M1? M1 is -3/5. So this means that M2 would be 5/3. Okay, M2 is 5/3. And the other thing which we know about this line is that it passes through the point 6 and -2. X coordinate is 6 and Y coordinate is -2. So part B is find the equation of L2 in the form y equals mx plus c, where m and c are constants. Okay, so we got our m, we got the gradient of the perpendicular line L2. So we have y equals 5/3 x plus c, and we need to find the c. In order to find the c, we will use this x coordinate and this y coordinate in this equation. So y is -2 equals 5/3 multiplied by 6 plus c. This is 1, this is 2. And I'm getting -2 equals 10 plus c. So this means that I'll take 10 to the other side and I will get -12 equals c. Okay. So c is -12, m is 5/3. I just have to plug in the value of c. So this means I will get y equals 5/3x minus 12 as the answer. Okay. Now again, this is the general form. M is the gradient and c is the constant. And we were able to find m using this concept, that the product of two slopes or two gradients would be -1 if both the lines are perpendicular. Okay, I knew the slope of m1, I was able to find the slope of m2 easily, right? And then using m2 and this point, I calculated c and I got y equals mx plus c for the line L2. Okay, now let's talk about the next question. That is this fourth question. Okay, so I need to zoom out a bit. Right, so figure 1 shows a line L1 with equation 2y equals x. So I can write it as y equals x by 2, because we know that general form of a straight line is y equals mx plus c. So y equals x by 2 is telling us that m is 0, m is 1/2 and c is 0. Okay, and a curve c with this equation, whatever it is. Okay, the region R shown, this is the region R, is unshaded and is bounded by the line L1. Okay, obviously it is bounded by the line L1, this part of the curve and the dotted line, right? Okay, so this is what we can see from the diagram as well. Given that L2 is parallel to the y-axis and passes through the intercept of C, with the positive x-axis, identify the inequalities that define R. Okay, just focus on this part. Identify the inequalities that define R. Okay, now let's go back to our diagram and forget about the information which they have shared, because everything is obvious on the diagram. We have to use some inequalities to explain the unshaded area R. Okay, the area which I'm shading with red, we need to use some inequalities in order to define this area. Now, what do we see? We see that this red area is outside this curve. It is outside this curve. So this is the curve. So this means that y greater than equal to 2x minus 1/8x square, right? Every region, including this line, which I'm shading with orange, and this region, right? All this region can be written this way, that y is greater than equal to this. Okay, now I will rub the extra orange lines I made. Okay, now we are done with this. What else do we know about this region? We know that this region is under the line L1. What is the equation of L1? This is the equation of L1, 2y equals x, and I have written it as y equals x by 2. Now I know that it is under this line, so I will write y is less than equal to x by 2. Okay. And what else do we know? This is the line. We are done with it. This was the part of curve. I'm done with that. And if I talk about the dotted line, what is the dotted line? This dotted line is basically x equals something. What something? We need to find that out. Okay. But for finding that out, we know that at this point, our curve is touching the x-axis. Okay, so this means that value of y is 0. In order to find this point, I can use the concept y equals 2x minus 1 by 8x square. I can use the value of y as 0 because on the x-axis, on this line which I'm writing or shading in purple, the value of y is 0. So 2x minus 1 by 8x square, I can take x common and I will get 2 minus 1 by 8x. Again, this is telling me either x is 0. Yes, this is x equals 0 and this point is 2 minus 1 by 8x equals 0. So this is going to give me minus 1 by 8x equals minus 2, and I can multiply this 8 on the other side and I will get x equals 16. So this is 1 and 6. This is 16. This point is 16 and this point is 1. Again, we are interested in finding out this region R, which I shaded initially. I know that it is bounded by the curve, the line L1 and this dotted line. We are done with the curve. We are done with the L1. We are interested in the equation of dotted line. It is a vertical line. So it would be y equals something. What something? Y equals 16. Okay. And it would be x less than 16. I did not write x less than equal to because this is a dotted line. So that region is not included, right? So this is the first inequality, this is the second one, and this is the third one. Using these three inequalities, I would be able to refer to this area R. Again, y greater than equal to because this is the curve and all the region greater than this, all the region greater than this is coming under this. Okay, then we are only interested in R, so we have just restricted the region as to less than L1. Okay, this was the equation of L1. By using this sign, I'm saying y is less than equal to x by 2. Why less than equal to? Because it is a solid line, it is not a dotted line. And for this line, I know that it is x equals 16. My region would be x is less than 16 and not equal to because it is a dotted line. Okay, so we are done with this as well. Let's talk about the next question. Okay, now state the coordinates of point P. Okay, let's read the question. Figure 2 shows a plot of part of the curve with equation y equals cos 2x with x being measured in radians. The point P shown on figure 2 is a minimum point on the curve. State the coordinates of P. Okay, now when we talk about coordinates, we know that we have x coordinate and y coordinate. Okay, if I talk about cos x, I would have said that this would be 2 pi, this would be pi, this would have been pi by 2 and stuff like that. But I repeat, this is for cos x. We are talking about cos 2x. So I have to divide all this by 2. So pi by 2 will become pi by 4. Simple pi will become pi by 2 and this will become 2 pi by 2. That is pi, right? So these are the x coordinates. Okay. And we are interested in point P. So the x coordinate of point P is pi by 2 and the y coordinate would be -1 because it is y equals cos 2x. We have a 1 here, okay? So this would be -1. Okay. So we are done with this. A copy of figure 2 called diagram 1 is shown at the top of the next page. Okay. So yeah, here it is. Okay. Sketch on diagram 1 the curve with equation y equals sine x. Okay. So they have given us cos 2x. Okay. This is the curve for y equals cos of 2x. And they want us to plot y equals sine x. Now there's a difference. Okay. Um, we know that this is pi by 2. This is pi and this would be 2 pi, right? Okay. Now, in order to plot sine x, we know that our graph is going to start from this point and it is going to go here like this. It would be of this type. And then again, it is going to come here and it would be of this type. Okay. Now, obviously, it is a rough sketch. Let me draw it neatly because this way we will end up getting wrong answers. Okay. So this is going to be of this type. Okay. And I will redraw this as well, just so it's neat. Okay. Now this is for y equals sine x. Okay. So this is 1, 2, and 3. Okay. So I have 3 intersections and I repeat, you have to be very, very careful that the black curve is for cos 2x and the pink one is for sine x. Okay. So there's a difference in both the angles. Okay. So we are done with the second part. Let's look at the third part. Hence or otherwise, deduce the number of solutions of the equation, this one, that lie in the region 0 to 2 pi. Okay, so hence means we have to use this, and they are saying for from the interval 0 to 20 pi. Okay, so we can see that from 0 to 2 pi we have 1, 2, and 3 intersections. So if it is 20 pi, the intersections would be, if it is 3 for 2, it would be 3 into 10 for 20, that is 30. Okay. And in the second part, it is again the same equation and this is the region. So we have 1 pi extra. So it would be 30 till 20 pi. And then again, if we start from 0 to pi, that is this point, we have 1 and 2. So till 20, the intersections would be 30, and from 20 pi to 21 pi, since we have 2 from 0 to pi, so we will have 2 from 20 to 21 pi. This is giving me 32. This is the answer of first part and this is the answer of second part. Okay. Let's talk about the next question. Right. Now here we have given f of x equals this, it is a function. Solve the equation this. Okay. Now what is the equation? F dash of x equals 0. First thing is first, what is f dash of x? Okay. So f dash of x is basically the derivative of this function. How do we find derivative? The power is multiplied. The power is 5 by 2. We had 2x. 5 by 2 minus 1 will give us 3 by 2 minus 40 equals 0. So this is how we differentiate. And since we were given that it is equal to 0, so we have written this equals 0. And next step is to simplify because we have been asked to solve. Solve means to find the values of x. Okay, so I can take 40 to the right side and divide it by 5. And this is giving me x to the 3 by 2 equals 8. And I know that x would be equal to 8 to the power 2 by 3. Since we have 3 by 2 here, I will write 8 to the 2 by 3, and that is x equals 4. Okay, so again, you were asked to solve this equation. Step 1 is to make the equation and then you have to solve it. So solving is easy. We just have to make x the subject and find its value. Making was a bit tricky. First, you have to differentiate and equate the derivative or the differential equals 0. Okay, and the second part is solve the equation f double derivative x equals 5. So what is the derivative? The derivative turned out to be, in other words, f dash of x turned out to be 5x to the power 3 by 2 minus 40. Now we are interested in f double derivative. That is going to be 5 multiplied by the power, that is 3 by 2, and 3 by 2 minus 1 is 1 by 2. Derivative of 40 would be 0, and this equals 5, we have been told. Okay, so we know that this 5 and this 5, they can be cancelled, and x 1 by 2 can be written as 2 by 3. Since this is 1 by 2, I'll square both sides and I will get x equals 2 by 3 square, that is 4 by 9. Okay, so this is how we first made our equation and then solved it. Okay, so today in this session we have done 6 questions. This was related to trigonometry, and you have to be very careful about this number. It is 2x. The whole thing is changed. In classes we have been talking about cos x, sin x, tan x, but this time it is 2 into x. Okay, so obviously our period and everything would change accordingly. Okay, and this question was about inequalities. We had to define the region using the inequalities. This question was about geometry, that the product of two gradients of two lines which are perpendicular is -1. Okay, this is a formula or a theorem, whatever you call it. You need to know this. This is a relationship between the gradients of two perpendicular lines. And then this was a simple question. We had to equate powers, and then the first question was of integration. Okay. So I hope that you guys must have understood so far. We'll do the next parts and the next questions in some other